All right, ladies and gentlemen, the next directions here ask us to find the zeros of the following functions algebraically, and it lists two functions for us. Okay, let's start with this one. The function f of x equals x squared minus x minus 2. Find the zeros. So in other words, we're trying to find the x values that will make the y value become 0. The function becomes 0. Which x values make the function itself, which is the y value, equal 0? So, I have this equation to solve. And it did ask me to do it algebraically, so it doesn't want me to just punch it into the calculator. All right, this equation I think is going to work very nicely with factoring because I think I'm going to have an x and an x, and I need a minus 2 and a plus 1. And it gives me the front, it gives me the back, and then the outer and the inner, the chin and grin, negative 2x and 1x give me a negative x in the middle. So I'm good. So if two things are multiplied together to give me 0, either the first factor is 0 or the second factor is 0. In this first case, x is positive 2, and in this case, x is negative 1. So those two numbers are the zeros of this function. And if you ever wanted to make sure that you did it correctly, when you plug a 2 in to this function, you should get 0, and you will. When you plug a negative 1 into this function, you should get 0, and you will. So that's how you can always check to see if you did it correctly. If this number is a correct answer, when you plug it in, you should get out the answer 0. And they both actually check. Okay, how about the next function? F of x equals x squared minus 6x, plus 6x minus 3. Well, if I'm trying to find the zeros, I want to know where the function becomes 0. In other words, what x values cause the y value to equal 0? Now, this is not going to factor, but me personally, instead of going to the quadratic formula, I'm going to use the square root property after I complete the square. And the reason completing the square came to mind, the leading coefficient is a 1, and the middle coefficient's divisible by 2. So remember to complete the square. You get your x's alone. So I would write x squared plus 6x equals positive 3. Get your constants alone and get your x's on one side, constants on the other. To come up with that magic number, we've been through this procedure. Half of 6 is 3, and 3 squared is 9. Okay, one more time. Half of 6 is 3. 3 squared is 9. Add 9 to both sides of the equation. This factors as x plus 3 quantity squared, and this becomes 12. And now we apply the square root property. All right? Blah blah squared equals a number, so blah blah is equal to plus or minus the square root of that number. To get x alone, I subtract 3. X is equal to a negative 3 plus or minus the square root of 12. All right? And there's one thing here that I'm not happy about. And that is, I know that 12 under a radical can be simplified. So let me turn my paper around a little bit. My answers right now look like this. Let me find them for you. Here we go. Negative 3 plus or minus root 12. But root 12 breaks apart into root 4 times root 3 using the product rule for radicals. So those answers become what? Negative 3 plus or minus 2 root 3. And now we're done. So those are the correct two answers for the problem. Negative 3 plus 2 root 3 and negative 3 minus 2 root 3. Those are the zeros of my function. And I guarantee you I'm not about to plug those back in to find out. I'm just going to believe myself. Okay, we're done.